Okay, so on the yellow paper, I'm starting on the part that says vertical asymptote. Cardarius, did you find it? Okay, so the reason I'm starting with this is because this is what we did yesterday, except instead of excluded values, now we're going to call it a vertical asymptote. So if I look right here, and I look at the denominator, what makes the denominator 0? So we're going to say the vertical asymptote is that x equals -2. Well, I'm telling you that's what it is. So number 2, can I factor the top? So I'm going to have x plus 7 and x minus 7. And on bottom I have x minus 7. And these cancel. Is there a value left on the bottom? So there is no vertical asymptote. There has to be a variable on bottom to have a vertical asymptote. Okay? There has to have a variable. Yeah. So if I factor the top here, I get 2 over x minus 4. And if I factor the bottom, I get x minus 4 times x plus 4. So what cancels? The x minus 4 and my vertical asymptote is x equals -4. And please put the x equals -4 because in a minute we're going to have a y equals, okay? So you need the x equals so I know it's the vertical asymptote. So on number 4, does anything cancel? No. So what are my vertical asymptotes? Very good. We want the x equals 0 from right here and the x equals -5 from right there. And on the next one, you have to factor on top. What can I take out? 2x, which leaves x minus 3 and an x on bottom. And so now what cancels? So do I have a value on bottom? No. So I have no vertical asymptote. So what I want to do now, these are the vertical asymptotes. So now I'm going to go back up to the top. These are called point discontinuity. And point discontinuity is actually what we've been doing all along. It's the open circles. So the open circle is the point discontinuity. And a point discontinuity happens when you cancel a term. So this has a point discontinuity, and this has a point discontinuity because I canceled, and this one also because I canceled a term. So where I cancel a term, there's going to be a point, and it's going to be missing. Isn't that kind of fun? Like you're figuring out what the open circle is all about. It's kind of fun, right? It doesn't exist, and I'm going to show you why. All right? Smile a little bit. Like make yourself, look how smart you're getting. I'm just so proud of all of you. All right. So on the next one, I can't do anything on top, but on bottom, what can I factor out? 3x, and that's going to leave me x minus 2. So what? But can I? How many x's are on top? How many are on bottom? So can I cancel out one of the x's? So if I cancel out this x, and it leaves me one x here. So I'm left with x over 3 times x minus 2, right? So the term that I canceled, which was x, right? Whatever term you cancel, you set it equal to 0. So my x equals 0. And this equals y. So I need to find the y value of the point I canceled. So I'm going to put a 0 in for y. Yes, x, I'm sorry. So I get 0 over -6, which is 0. So my point discontinuity is 0, 0. So on this one, x squared minus x minus 6, that factors to x minus 3 and x plus 2. And on bottom, we factor to x plus 3 and x minus 3. So what cancels? So my y is going to be x plus 2 over x plus 3. So what term did I cancel? So x minus 3, if I set it equal to 0, what does x equal? So that's the x to find it. Now I have to take this 3 and put it in for y. So I'm going to get 3 plus 2 over 3 plus 3, which gives me 5, 6. So, okay, look. No, so whatever you cross out, you set it equal to 0. So it's a positive 3, right? I could have made that mistake. So it's positive 3. And when I plug it in then, 3 plus 2 gives me 5, and 3 plus 3 gives me 6. So my point discontinuity this time is 3 and 5, 6. So what can you factor from the next one? 2x. So what cancels? So I'm going to set 2x equal to 0. So my x equals 0. And if I take that x and I plug it back in for y, I get 0 and negative 3. That's the point discontinuity. So we found the point discontinuity. What is the vertical asymptote for the first one? X equals 2. The vertical asymptote for the second one, x equals negative 3. And the vertical asymptote for the last one? None, because there's no x on bottom. Okay, so we found the vertical asymptote and the point discontinuity. Is everybody okie dokie? All right, turn the page over. So vertical asymptote is through the x. The horizontal asymptote is through the y. And we have 3 different kinds. And I'm going to start with the bottom heavy one. It's in the middle. So to find the horizontal asymptote, I'm looking at the exponents. So what's the exponent on the first one? How many x's are there? I'm on number 3. Sorry. So there's no x's on top, and there's 1 x on bottom, right? So 0 over 1, that's bottom heavy. That's higher exponent on bottom than on top. So when there's higher on bottom than on top, our horizontal asymptote is y equals 0. So look at number 4. What's the highest exponent on top? And the highest exponent on bottom? 2. Bottom heavy, the horizontal asymptote is y equals 0. Okay, we're going to do top heavy in just a minute. Okay, so bottom heavy, y equals 0. So now go to the top heavy, which is above that. So on this one, I have 2 over 1, which means it's top heavy, and there is none for a horizontal asymptote when it's top heavy. 3 over 2, the horizontal asymptote is none. Where? I just want the highest one. You don't even, just look down the line. What's the highest exponent? Don't even have to combine. You don't even. So the only time you would have to do that is if it was multiplied, right? Then you'd have to add them up to get your total. But none of these are multiplying. They're just all plus, so just the highest exponent. Okay, so the bottom, number 5 and 6, this is when it's tied. So this is a 1, and this is a 1, and it's tied. And that's when you look at the coefficient. So the coefficient here is 2, and it's 5 on bottom. So the horizontal asymptote is y equals 2/5. So this one is 2 over 2. It's tied. So this is 2 over 2. And what does that reduce to? Bless you. So this is the horizontal asymptotes. All right? All right. So turn back to the front where it says vertical asymptotes. And look at number 3. So we found the vertical asymptote by looking at the bottom, right? So what canceled here? So x minus 4 equals 0. So to find the point discontinuity, I would have 4, and if this is 2 over x plus 4, I would get 2 over 8, which would be 1/4. Use the cancel. I used this one right here and plugged it in here, which makes 2 over 4 plus 4. In the canceled one. So once I get this, go back to the original equation. I have 1 and I have 2. It's bottom heavy, so what's the horizontal asymptote? Y equals 0. You are. Or, I'm not done yet, or we could go on to the gold paper. Okay, so the gold paper talks about, the first thing it's going to talk about is the domain. And the domain is easy because we're going to restrict the domain with our vertical asymptotes. And for those of you who don't remember from the very first page, that means the bottom, right? We're restricting on the bottom. So for number 1, if I factor the vertical asymptotes are -5 and 5. No. But you can do this then for the domain. We're going to write all reals, and x cannot equal -5 or 5. Bless you. So number 2, what's the vertical asymptote? X is a positive 11. So the domain is all reals except x can equal 11. And the last one, I can factor the, can I factor the bottom? It's positive. I can't factor it, so there is no vertical asymptote. So the domain would be all reals. All reals except the vertical asymptote. Okay, you do, but what happens when I subtract the 25? It comes an imaginary number, and remember, we're only doing the reals. We talked about only reals, only what I can put on the graph. Okay? Okay. So the domain is the only thing you're going to do before you cancel things. Everything else you do after you cancel. All right? So the domain is before you cancel, but the x-intercepts and everything else is after you do your canceling. So to find the x-intercepts, I use the bottom to find the vertical asymptote. I'm going to use the top to find the x-intercept. So whatever's on top, set it equal to 0, and what does x equal? So the x-intercept is negative 5, 0. So I'm going to factor just to check, but nothing's going to cancel on bottom. So I'm going to use this to find the x-intercept. Yep. X squared minus x minus 20 factors to x minus 5, x plus 4. The bottom factors to x plus 3 and x minus 3. So nothing cancels. So I have to use this to find my x-intercepts. So how many x-intercepts do I have? 2. So we already factored the top. It's x minus 5 and x plus 4. And this time on bottom, it's x plus 4 and x minus 4. So what cancels? The x plus 4 cancels. So that's a point discontinuity. So the only x-intercept I have is 5 and 0. The bottom you use to find the vertical asymptote. Top x, bottom vertical, exponents horizontal, domain, everything except the vertical asymptotes. So if I have an x-intercept, what do I also have? Y-intercept. So what does x always equal for the y-intercept? 0. So if I fill in a 0, so my y-intercept we have to find this after reducing. So I'm going to factor on top. And what cancels? The x plus 3 cancels. So my y-intercept I find by plugging in 0. Gives me negative 3. On number 10, does anything cancel? No. What happens if I put a 0 there? What? Can I divide by 0? No, so the y-intercept is none.